So in this video, we're going to see an interesting topic with respect to chapter number 12, Heron's formula. And the topic reads, applications of Heron's formula in finding areas of quadrilateral. Now this is very interesting because so far we have seen Heron's formula to find out the area of a triangle. So I'm just going to make a note of that. So we have used Heron's formula to find the area of a triangle. Okay, when all the three sides of a triangle are known to us or are given to us, we can find the area of a triangle using a Heron's formula. Now we can extend this idea of Heron's formula to find the area of quadrilaterals. Okay, so we all know what is quadrilateral. Quadrilateral is a geometrical figure which has four sides. Okay, four vertices, four sides, four angles, and all the 4 points, all the vertices of quadrilateral are connected in a linear fashion. For example, let's come here. Okay, so we are trying to understand what a quadrilateral is. So in quadrilateral there will be 4 points. There are 4 points, and the way you connect these 4 points is in a one rotation. Like if you start from this way, then this is how you should go about it. Okay, you cannot connect these four dots like this, like 1 2 3 4. No, you cannot cross over each other. They have to be connected in a serial fashion. Okay, so these were your four dots. So that is a quick definition of quadrilateral. Now we will see how we can use Heron's formula to find the area of a quadrilateral. So here are some quadrilaterals which are hidden behind the slides. We'll remove one by one and see how this concept can be applied. Okay, so this is a very simple quadrilateral. Once again, you have these 4 points 1, 2, 3, 4, and imagine that you are given the sides of all these four quadrilateral. You are given the measures of sides of all the four sides of quadrilateral. So if this is A, okay, this is B, this is C, and this is D. Okay, let's say these four lengths are given to us, and I am asking you to find the area of a quadrilateral. So what we do is, since we have to use Heron's formula, okay, since we have to use Heron's formula, which is basically area of triangle, we divide a quadrilateral into triangles. And how are we going to do that? Just connect in this quadrilateral, we just connect this diagonal. Let me use a straight line. So we just connect this like this. Now, as you can see that this is one triangle, okay, and this is one triangle. Now, all you have to do is measure the length of this diagonal. Okay, let's call it E. Let's call this as E. And thus, we have two triangles. Let me use a highlighter here. So we have two triangles. This is one triangle. We can again find its area using Heron's formula. And this is another triangle. We can find the area of this triangle also using Heron's formula. And finally, we have to add both these areas of this triangle and this triangle to get the area of the whole quadrilateral. Okay, so very simple, straightforward, and kind of a very intuitive concept that if you have to find the area of quadrilateral using Heron's formula, then basically divide it into triangles and then add the areas of all the inner triangles. Okay, so this was a very simple quadrilateral here that we had. Let's try to see a little bit complicated quadrilateral. So I'm going to remove this. Okay, so once again, let's confirm that it's really a quadrilateral. So I'm going to use, so this is 1 point, second point, third point, 4 points. There are 4 points. Okay, and you can see they are connected in a one linear fashion. Okay, once you start this way, then you go here. There is no cross connections. Now, once again, if I have to find the area of this quadrilateral, I need to cut it into different triangles. So what we are going to do is same thing what we did before. Try to connect these two dots, and if I connect these two dots here, yes, you can see I've got two triangles. So once again, let's use the highlighter. This is first triangle. Okay, we can find the area of this triangle using Heron's formula. And once again, we can find the area of this triangle also using the Heron's formula. Of course, what we're going to need is the measures of these sides. So we should know, let's say this is A, this is B, this is C, this is D, let's say this one is E. Once you know the measure of these all lengths, you can easily find the area of the whole quadrilateral. Okay, area of the whole quadrilateral just using the Heron's formula. Now, one more quadrilateral is there. Let's try to get rid of this. Okay, so same thing, this is also a similar quadrilateral with, you can say, 4 points, 2, 3, 4, 4 vertices. Once again, connect any two middle vertices to form, okay, to form the triangles. So divide a quadrilateral into two triangles. As you can very clearly see in this diagram, this is triangle number 1, this is triangle number 2. Okay, all we need is the length of these sides. So this is A, this is B, let's say this is C, let's say this is D, and let's say this new constructed line is E. And now we have lengths of all the sides of these two triangles. You can easily find the area of triangle number 1, triangle number 2 using Heron's formula, and then add the areas. So again, quite simple. There is nothing complicated in this concept that we saw in this video. We are applying, okay, we are applying this Heron's formula. Let's highlight it. We are applying this Heron's formula to find the area of a quadrilateral just by cutting it into different triangles. So in the next problems that we are going to see, we are going to use this extensively. A quadrilateral will be given to us, and we will be given a lot of inner triangles inside the quadrilateral, and we have to find the area of the whole quadrilateral using Heron's formula multiple times for all the different inner triangles that the quadrilateral will have. So let's use this concept to solve some interesting unsolved problems.